So what if stateless packet filters are not good enough for the job that you're trying to do? Maybe you've come up with a very complicated set of rules where you want to keep track of all these different things. Maybe you want to allow the first 100 packets, but after that you want to start blocking any more packets after that. Well, those kinds of rules require stateful packet filters where you have to keep track of what you've previously seen. That way you can implement those more complicated rules. So more specifically, with stateful packet filters, the firewall is usually keeping track of what connections are active. So when it notices that a bunch of packets are going back and forth between the same two computers, the stateful packet filter will write down that those two computers seem to be having an active connection. So in other words, we're sort of moving away from thinking about individual packets flying across the network with no correlation. And with stateful packet filters, we're moving toward thinking about connections, where two people have a long-lasting connection and are sending lots of data back and forth. So the stateful packet filter might have a little table remembering what connections are currently active. It seems like these two people are talking, and these two people are also talking, and these two people are also talking. And then when packets are sent, we can use rules to decide what connections are allowed or dropped. So now that we're keeping track of this big table of active connections, we can write more complicated rules like this. We could say, let's allow everything from this computer, maybe that's an internal employee, or maybe that's someone outside, to this computer with destination port 80. So maybe this means that this computer is on the outside, and they can access this computer on the inside, but only if they use TCP port 80. So they can access the application living on port 80, but they cannot access applications living on other ports. The firewall would drop that. That's one example of a rule that you could write. List an outside host, say that they're allowed to send packets to this inside host only with this destination port only, and maybe all the other ports are not allowed. You could also write more general rules, like let's allow anybody from inside, and INT here is short for everybody on the inside, and let's allow them to send connections to anybody on the outside, that's what EXT stands for, but only if it's port 80. So in other words, every employee on the inside of your company network can send packets to anybody on the outside, but only if they use TCP port 80, which usually corresponds to HTTP. But we won't allow other types of connections. So the star here is like a wildcard. It represents any IP address, any port inside. And here, this is any IP address, only port 80 on the outside. Now, maybe you want to allow all outbound connections, like we did earlier. In that case, you might say, I'm going to allow everybody on the inside to talk to everybody on the outside. Once again, wildcard for any IP, any port, INT for internal, any port, or any IP, any port, anybody on the outside, EXT for external. It's kind of syntax heavy, but that's what this line means. And so I won't go through all the examples, but the last one would be anybody from the outside to this internal host, but only destination port 80. So you might decide, if you're Google, for example, that the web server that's being used to process search requests, maybe that's 1.2.2.3, port 80, that's allowed for anybody outside to contact. But the server that stores everyone's passwords, that is not allowed for outside hosts to contact. So the firewall might say, you can contact the web server to make Google searches, but you cannot contact the server that's storing our passwords or doing some other sensitive data or computation. So those are some examples of stateful packet rules. Now, if you want to get even more complicated, the stateful packet filters could think beyond layer 4. So far, we're thinking about connections, like TCP connections, which are at layer 4. But the stateful packet filter could get even more complex and actually look inside layer 7. So maybe the stateful packet filter actually looks at layer 7. So it unwraps that layer 4 header and looks at the layer 7 header and payload. And maybe it decides to keep track of what HTTP requests and responses are being sent. So maybe you only allow GET requests, but you don't allow post requests. That could be something that a stateful packet filter could do by opening up the packet and looking at the HTTP response inside. Or maybe you can track what files are being sent. You might say that sending PDF files is allowed, but sending videos is not allowed. Those are all sorts of things you can do by having a stateful packet filter keep track of the connection. So if you want, you can read this on your own, but it's just an example of a rule that someone might want to use on their firewall. And all we're showing here is just that the packet filter has to keep track of a bunch of state. So it has to remember all these different pieces of information in order to decide whether or not the packet is allowed.